Okay, so today we're going to finish up law of sines. Okay, we've looked at the case where we had angle, side, angle. You never have to worry about more than one solution in that case. Always has one. Okay, we looked at angle, angle, side. Never have to worry about more than one solution. The last one we looked at was side, side, angle. Okay. In side, side, angle, you have to check for two solutions and for no solution. Okay. That is the only case that you'll ever have to check for two solutions out of every one we do. All right, so just a reminder, there's your law of sines again. When we are doing law of sines, how many parts of it do we use at a time? Or I guess how many fractions do you use at a time? Two, right? Two at a time. Okay. So let's see if we can solve this. All right, so we could make a diagram to figure out which one of the three types of problems that is, or if you know what you're looking for in the table, you can tell by that. What's something that happens in this table that's important? And then I'm going to ask you what that fact tells you about the problem. Anything in that table that's important? Anything you notice about it? Yep.
You're given two sides and an angle.
Okay. Can you tell me more about the table?
You have one complete row and one empty row.
Okay, we do have one complete row and one empty row. What does one complete row tell you?
That it is sine.
Yes, it tells you that this is a law of sines problem. And the fact that the row is empty at the bottom and you have no way to find anything in that row right away, that tells you it's the no solution, one solution, two solution. Okay. So because we don't have anything in the bottom row, we're forced to find what first?
Second.
Beta. Yep. So let's set it up and let's find beta. Get every law of sines problem starts out just like that. What could I fill in on the left side? Yep.
Sine 35 of 46.
Okay, so we're going to do sine 35 degrees over 6. Yep. And what's going to go on the right side if we are finding beta? Yeah.
Sine beta over 8.
Sine beta over 8. Perfect. Okay. All right, next step. We got to get the sine beta alone. What would I do on each side to do that? Yeah. Yeah, multiply both sides by 8. Now, yes, you could reduce 8 over 6, but we're going to just type it in on a calculator. And whether you type an 8 and a 6, or you reduce it by 2 and do 4 and 3, it doesn't really save you much. So I would just leave it the way it is. 8 sine 35 over 6. Okay, so that number is equal to the sine of our angle. So how are we going to get the angle itself? Yeah. Yep. Take the inverse sine of what's on the left and what's on the right. Okay, right side's going to cancel out the sine and the inverse. And now type in what's on the left. Okay, at this point, one of two things always happens. You either get a number as an answer, or the calculator gives you an error. Okay. So let's do inverse sine. 8 sine 35 over 6. Okay. As long as we did everything right up to that step, which we did, this is not a no solution problem. I know that because I just got a solution. Okay, so 49.886. So we're going to write that in the box for beta. All right, now we're going to check for the second answer. How do I find the second answer from the first one?
You add those two up and subtract.
Nope.
You subtract them both from 180?
That's what I just said.
No. Yep.
Subtract the answer you just got from 180.
Right. 180 minus 49. Okay.
We
So
don't
you
know.
take 180
What was that? You said after them both. It's only the one.
and then subtract 49.886. If it's the last thing you typed in, you can just press second answer. Okay. So that is the second answer if it works. Now we have to determine if it works. Yeah.
Oh, nothing. I just need the second answer because the 35 is hard.
Right. So what do we think? Does this second answer work?
Yeah, that's right now.
Yeah. Right? Because what angle were we given? We were given 35, and if you add that to 130, what do you get?
165.
You get 165. So when you add the second answer to what you were given, you are under 180, which means you need to write it down. So that means beta has two answers. Okay, so what we're going to do is this. We're going to have two answers in that box. Call it beta 1, beta 2. 130.116. No, I'm sorry, 130.114.
36. No.
Yeah, I could do 3, 6, or I'll just do 4. We don't, I mean, if you want to go to that many, you can, but 3 decimal places is fine. All right, now, because beta has two answers, that means everything we need to find now has two answers. As far as the stuff that was given, don't worry about what was given. That's done. So A, B, and alpha, that's fine. But what you don't know, C, beta, and gamma, will all have two different answers. All right. So if I wanted to, I could kind of like color code it and show you how we're doing two problems. Alpha is going to be part of, we'll call it the blue problem. Beta 1 is in the blue problem. Gamma 1 is in the blue problem. Those are the three angles in the blue problem. Okay. In the green problem, we have alpha. So yes, alpha is in both. Beta 2 and gamma 2. Those are your three angles in the green problem. Okay. Alpha is what we call a shared angle. It's in both. Now, if you wanted to match up the sides, so you know what sides are in each problem. A is in the blue problem, so is B, and so is C1. Those are the three sides in the blue problem. Okay, green problem. A, B, and C2. So again, we have some shared information. A and B are in both of the problems we're solving. So what we could do is you could make two different tables if you want. Right? Or you can just do it all in one table. That's how I do it. All right, let's finish off the gammas. How are we going to get gamma 1? Yeah.
You could add alpha and beta 1 and subtract it from 180.
Yep. We're going to subtract alpha and beta 1 from 180, and that'll give us gamma 1. Okay, on this calculator, you can just do them one at a time like that, and that'll work fine. So 49.886, that is gamma 1, 95.114. All right, so you could go and do C1 now. You've got enough information, you could finish that. Or I like to just get all the angles done and then I'll go do all the sides. All right, how are we going to get gamma 2? Christian?
Take alpha 1 and beta 2 subtract from 180.
Can you just say that again?
You're going to take alpha and beta 2 and
Yep.
subtract from 180.
Yes. So we're going to take alpha, beta 2, and then subtract from 180. All right, so if you add beta 2 and alpha, that's 165.114. So 180 minus 165.114. If you get a negative answer there, then you made a mistake with the second answer. You probably should not have used it. Okay. But we already know the second answer works, so we get a good answer, 14.886. Okay. So now we've done all our angles. All right, so we'll finish it up and find our sides. Let's do, doesn't matter if we do C1 or C2 next. Do either one. So this will be for C1. The other side will be for C2. Okay, C1. What problem is that a part of?
Blue.
The blue, yeah, if you want to call it the first problem or the blue problem, however you want to think of it, it's the blue problem. So to solve for C1, it's in the blue problem. I need a blue row that has everything in it. What would be a row that's full and in the blue problem? Yep, the first row. You could use the B and the beta 1, but if we can stay away from the decimal, that's better. So let's stick with A and alpha. Sine 35 over 6. Equals. And if we're going to find C1, what's the angle I have to use?
Gamma 1.
Get 1, 95.114. Okay, I'll come back and I'll solve that in a minute. For C2, you need a green row. Well, A and alpha is also in the green problem. Okay, it's in both. So we'll use that. And what's the angle we're going to use to find C2?
Gamma
Gamma 2, which is
14.886.
14.886. Okay, so multiply the two that are on the diagonal that don't have a variable, and then divide by the one that's on the diagonal with the variable. Okay, so you've got 6 sine 95, 114. Make sure you close your parenthesis. It doesn't really matter if I close it after the 5 here. That's 10.419. So that's the answer for C1. And C2. What's the only thing I have to change to do C2? Bob, Tom.
We'd have to change the link, like the measurement that you used,
So yeah, what would you change in that?
I wasn't paying attention.
All right, anyone help them out? What would you change, Ricky?
I would change the 95 to the 14.886.
Yeah, you just change 95 to 14. Other than that, the 35 and the 6 are exactly the same because you're using them again. So if you don't want to retype it, you press second and you press enter, and it'll bring up the last thing you just typed. 14.886. Make sure I got everything else right. Looks good. And we get 2.687. Okay, so 10.419, 2.687. There you go. That's a two-solution problem. Guys, I don't think the two solution is necessarily harder, it's just longer. you have to do the same thing twice. But it's the same thing. It's not any different, right? Just double the answers. All right, so now you've seen what happens when you have a 2 solution. Last night in the homework, you had a 1 solution. Well, let's see what's going to happen here. Okay, first of all, what does this table tell us? Without making a diagram.
A full row on the bottom.
Yep, you got a full row, which means something very important.
It's
Right, this is law of signs. If you're wondering, well, how could you not have a full row? Well, if I gave you a side, a side, and a side, that's not a full row. That'll be tomorrow, Thursday. Okay, so what should we try to find first? Yeah, alpha. Do we have any other option that we could even try to find first?
Nah.
Okay, set up your law of signs. Anybody tell me what's going to go on the left? Yeah.
Sine 50 on the left.
Yep. And if you put that on the right, that's fine. You just need sign a 50 in the top, a 1 in the bottom, and you could put that on the left or the right. Just keep the 50 and the 1 together on the same side. And now, because we put that on the left, what's going to go on the right?
Sine alpha over 2.
Sine alpha over 2. Okay, 2 steps to get alpha by itself. Okay, what's my first step there? Yep, multiply both sides by 2. Because the sine of 50 is divided by 1, I'm not going to worry about dividing by 1. Okay. Does dividing by 1 change anything? Okay, so we got it. 2 sine 50 equals sine alpha. And my last step to get alpha by itself?
Take the inverse sine
So, again, just to be clear about that, that is multiplication right there. 2 times the sine of 50. Sine 50, that's not multiplication. Inverse sine of everything in the parentheses, there's no multiplication right here. That's just a parenthesis that's telling you that's where your argument starts. It's not a parenthesis that means multiplication. So parentheses can mean different things in math. It does not mean multiplication here. Okay. So now let's type that in and see what we got. Second, inverse sine of 2 sine 50. Oh, I got an error. Somebody else try that?
Sure.
You got an error too? Okay. Did you type it in right?
Yeah.
You did?
How do you do?
Yeah, I did too. So it is an error, which means
No solution.
this one has no solution. When was it? I think it was last week. We did the graphs of sine and cosine, right? What was the highest and lowest that the graph normally went? Yeah?
When I'm 1, negative
1 and negative 1. Look at what 2 sine 50 is. It's 1.5. So when you try to take the inverse sine of 1.5, you're basically asking me this question. You're asking me where that graph and the line that I'm about to draw on the screen cross each other. Where does that graph, did I type in 1.5? Oh. Let's speed it up. Where do the 2 graphs that are on the screen cross each other? They don't.
They literally don't.
If you've got a number here that's bigger than 1, and you try to take the inverse sine of it, it won't work. Okay? So that means alpha does not have a solution. Now, at this step, you would normally add the angle you just got to gamma and subtract from 180. But I didn't get an answer for alpha. So what do you think that means about beta?
No solution.
Yeah, I can't find that one either. And if you can't find an angle, you definitely cannot find the side that's across from it.
I like that problem, it's easy.
Yeah, that's the quick one. So the three things that can happen is you either get no solution, no solution, no solution. They're all no solution. 1, 1, and 1. They're all one solution. Or 2, 2, and 2. They're all 2. Those are the only three things that can happen. So what that means, like if you physically tried to make this triangle, you'd have 3 sides, but it's like they wouldn't meet. They wouldn't be long enough to connect. And you wouldn't be able to change this angle because it has to stay 50 degrees. Right? If you could change the angle, then yeah, you could rotate that side and make it connect. But with that information, it just would not make a triangle. All right, so any question on the no solution? All right. So the last one we're going to look at is a word problem. Most word problems are not 2 solution. Okay, the ones I give you. That's because the problem is usually going to be about like measuring the height of like a mountain or finding an object. And if you're measuring the height of a mountain, it's not going to be 2 different answers. Like the height of the mountain is one height. There is one answer for it. So you're not going to get 2. All right, so the way that this is going to work is basically what's called triangulation. Triangulation is when you basically look at the same object from 2 different reference points. You can either look at it yourself from 2 different points, which is easy to do if the object you're looking at is not moving. You could look at it today, and then tomorrow come back and look at it from a different spot. But if the object you're trying to look at is currently moving, then you can't do that. You'd need 2 people that can see the object instantly at the same time. Because if you drive to another spot and your object moved that you're looking at, then the first time you looked at it, it doesn't help anymore because it's not in the same spot. Right? So we're going to be finding the height of a mountain, and we're going to look at it from 2 different spots. In order to find the height of the mountain, the surveyor is going to take what's called a sighting of the peak. So what that means is they're going to set up a device, maybe like a transit. They're going to look through it. Sometimes you see these like on the side of the road, like if you're driving, you see someone with like a tripod, and then if you drive a little bit further, you see like another tripod, and the guys are like looking through it. People know what I mean? Sometimes you see those. They could be measuring. They could be measuring like the grade of the road. Make sure like water runs off it. They could be measuring property to figure out where one property starts and another one ends. They could be measuring all kinds of stuff. All right, but this survey is going to take 2 sightings of the peak. So they're going to set up their transit. They're going to look through a scope. They're going to point a laser at the mountain. And the first time they do that, they're going to get an angle of elevation of 47 degrees. So what that means is if the transit was like on the ground, that's how much they have to turn the transit, like rotate it upward, so it's pointing at the top of the mountain. And then they're going to do that one more time, but they're going to back up 900 meters when they do it the second time. You do have to know how far you move backwards when you look at it the second time. Okay. As you back away from something, the angle to it decreases. Think about like if you had a screen in front of you, right? If you were like sitting right there on the floor and trying to look at this screen. If you're right there, you have to look almost straight up, be very steep. But then if you sit on the floor in the back, you wouldn't have to look straight up. You could look at less of an angle because you're further away. Now, technically, the device that they use to measure transit, it is on a tripod. So we should add in the height of the tripod to the answer we get. Because we're really only going to be finding the height of the mountain from the top of the tripod to the top of the mountain. But the tripod's only probably like 5 or 6 feet. So it doesn't make a huge difference. So we're going to assume that the transit with the laser on it is on the ground. It's not on a tripod. Okay, so there's a lot of information there. What do you think is going to help us to kind of see what's going on a little better here? Yeah.
Dry.
Yeah, we're going to draw it. And when we draw it, for now, we're not worried about labeling numbers and things like that. I want to put objects in the problem. Okay, important objects or important reference points that are described here. So what are some important objects in this word problem that we need to draw? Yep.
Mountain.
The mountain, and something without this we can't even have the mountain. Something even more basic than that.
The ground.
Yeah, we need the ground. They tell us the ground is level, which means it's flat, and we need a mountain on the ground. So let's start with that. There's our ground. Okay, mountain. There we go. There's our mountain. All right, so we got those two things. What else is important to put in the diagram? Yep.
Peak.
Okay, so the peak of the mountain, we got that, yep. So that's the top of the triangle, yep.
Surveyors.
Right, the surveyor, right? Whether it's 2 surveyors or the same person just doing it twice, that doesn't matter. But we know that they're going to observe the mountain from here, and they're going to back up again and observe it from there. So that's our surveyor. What do we know about the distance between the 2 surveyors? Now we need numbers now. Yep.
It's 900 meters apart.
Okay, so they're 900 meters apart. And they're going to shoot an angle to the top of the mountain. So this represents kind of like a laser being pointed right at the top. They do it once, then they do it a second time, just like that. So 2 different sightings. Okay, so for the first sighting, what do we know about the angle of the laser when it's pointed up at the peak? Yeah.
It's 47 meters.
So it's 47 degrees, and that's right here. That's the angle that the laser was tilted up with the ground. And how about the second time?
35.
It was 35? Okay. All right. And what are we trying to find? The height. Yeah, of the what?
Of the mountain.
Yeah, we're trying to find the height of the mountain. So is this line right here, like, is that the height of the mountain? No. Is that the height of the mountain?
No.
No, that's not straight. So the height of the mountain is something like that. That's the height of the mountain. Like if there was a hole in the top, you could drop something straight down to the bottom, like a volcano or something. Right? So the height is straight down. Let's label that height. And that's a 90-degree angle. Okay, so here is a triangle that we would like to work with. We've got that 90, that perpendicular coming straight down. We've got that. And we've got that. I don't think I drew the sides quick enough for it to all stay together. No, I didn't. All right, I'm just going to move that down here. Okay, so there's our triangle. And the goal is just to find the height of that triangle. Okay. That's the height. That's a 90. And what else do we know in that picture?
The angle.
Yeah, which one?
The bottom left one.
Yep. And we could find the top one if we wanted. That's not really going to do anything for me. But I could if I needed it. Okay. Do I have enough information to work with this triangle?
Yeah.
No. What don't I have that I would need?
The length or something.
I need at least one side. So that's the triangle that I want to work with, but I can't. I don't know one side. Until I can figure out a side in that triangle, we need to just put that off to the side. Right, so let's look at another triangle. Does anybody see another triangle that we can make in this diagram? And it kind of has something to do with the blue one. Just tell me like the sides you would use to make this other triangle. Yeah?
I'm not sure if I'm right. Can we go from that first place that we stood at?
Yeah.
Second one?
From here to the second one,
Yeah, to the peak.
to the
Back
peak,
to the first spot.
and back to the first one. Yep. That's the triangle we need to work with. Now I said that that one has something to do with the blue one. What does it have to do with the blue one?
Well, if you flip the 47 degrees around, that would give you the degree on the bottom right, wouldn't it? Because like,
Well, yeah, I can get this from that, so that's
Yeah,
important.
yeah.
What else does the red one have to do with the blue one?
That's the side of it.
It has a side that's the same, right there. So if you can figure out the right-hand side of the red triangle, then you will know the hypotenuse of the blue triangle. They're the same thing. Any question on that? So let's label the red triangle and see if we have enough information to work with that. Okay. What's the bottom side?
900,
That's 900. How about this angle on the left?
35.
35. And how would you find this angle on the bottom right? Yeah.
Subtract 47 from 180.
Yeah, these two make a straight line right there. So if you subtract 47 from 180, you will get that angle, 133. Okay. Do we have enough information to work with that red triangle? Yeah, definitely. That is angle, side, angle. That's one of the three types we said you can use law of sines for. Now, to use law of sines, you have to have a full row. Visually, a full row means you know an angle and you know the side across from it. Looking at the red one, do I have an angle and a side across from it labeled right now? What do you think? Do we have an angle and a side across from it, both labeled with numbers? No. We don't. We don't know. We don't have the one across from the 35. We don't have the side labeled across from the 133. And here's the 900, but we don't have that angle labeled either. So what am I going to be able to figure out then? There's something there that I can find. And then you will know an angle, and you will know the side across from it. Yep.
The third angle?
Yeah, you can get this third angle. You don't know it, but you can find it. How can you find it?
You can subtract 133 and 35 from 180.
Yeah, take the two that you have and subtract from 180. So 180 minus 35 minus 133 gives me 12. Yeah. All right. Now we have an angle and we had a side across from it. Okay. We don't have to find everything in the red triangle. We only have to find one thing that's going to help us in the blue triangle. What is it that I want to know in the red triangle that I don't know? Yeah?
The right side.
I want the right side. So you can call it whatever you want. There's no labels in this picture, so I would just call it A. All right, let's solve for A. All right, so the left side, I like to put everything that we know. Can somebody tell me what you would put on the left side? And this is not going to have any letters. Yep.
Sine 12.
Yep.
900.
Sine of an angle, divide by what's across from it. That's your full row. And now, if we want to find A, what would go on the right side? Yeah.
Sine 35.
Sine of an angle,
And
and then divide by what's across from it. Okay, and remember what we're finding. A is really like that side right there. All right, so let's do that. 900 sine 35, and then you're going to divide by sine 12. Okay, so it's 2482.88. 2482.88. And I think it was meters. Yeah, meters. Okay. So is that the height of the mountain?
No.
No. What is the 2482.88 in the blue triangle? It's the hypotenuse. Yep. Now, you got enough information to work with the blue triangle. You got an angle, and you got a side. Okay, so look at the two pieces of information you know. Look at the piece of information you want to find, and figure out what trig function we need. What position is H in relative to 47? That's opposite. What position is the 2482.88 in?
Adjacent. Oh, sorry, hypotenuse.
That's hypotenuse, because it's across from the 90. What trig function involves opposite and hypotenuse? Tangent would be opposite and adjacent. Sine, yep. So, John, can you set that up for me? Sine of what equals what?
Sine of H with so it's going to be sine of H.
Sine of, what kind of thing do you always fill into a trig function?
Oh, yeah, angle. So
An angle.
sine of 47 degrees
Sine of 47. Yep.
is going to be opposite, which is going to be H over 2482.88.
2482.88. Okay, and my last step, how am I going to get H by itself there? Multiply, yep. So 2480, well actually I already have that typed in, so just use the answer that I just had times sine 47. Okay, so the height of the mountain is about 1,815.86 meters. So that's the kind of problem where what they want you to find, you can't do right away. You have to find another side first. It's kind of like a helper side. You get that first, then you can get the answer they really want. Okay. All right, any questions on that? All right, every word problem's a little different, so I can't really show you how to do every one of them, but it all usually comes down to drawing a picture, and you're going to end up with triangles in the picture somehow. Okay. So that is the homework for tonight. So it's 267, 29 to 35 odd, 39, and 43. It is possible you have a no solution, so don't think you did something wrong. If you get no solution for every problem, then you definitely did something wrong. They're not all no solution, but there's some. And remember, we don't have class tomorrow. So periods tomorrow are 5, 6, 7, 8, 9. We'll check that on Thursday, and then we'll start and finish law of cosines. And our test will be on Friday.